Well, thanks everybody for coming here. It's I think my fourth time in Kiev. I was here last year as well for the UA Mobile, and I love to come here. Nice beer, very cheap compared to Germany where I live. So today, as you know, I'm gonna be talking about TensorFlow for mobile developers. Just very shortly about me, I'm a freelance developer. I'm originally from Madrid and live in Munich. I'm the only Spaniard that doesn't watch soccer. And yeah, I'm part of the Google Developer Expert program. And this is my Twitter handle. I will post the slides later. If you have any question or want to engage in any conversation, just feel free to ping me there. Before I keep going, how many people here has experience with TensorFlow? Okay. And machine learning? Okay. How many in production? Huh. So that leads me to this. I don't know if you know this Twitter account. I'm a developer. He posted some humor-based content, and that one caught my eye. I think it's something that happens a lot in the community. We get very engaged with machine learning, artificial intelligence, because we like to try the latest trends and download the latest libraries. But we don't do it on production very often. We just do it on our free time, see what's cool and what's not. And that's one of the big issues for adoption of machine learning. I also saw this tweet that what used to be called an algorithm, now we call it artificial intelligence. And apparently now everything is artificial intelligence. There is a boundary that is a little bit fuzzy between artificial intelligence, machine learning, algorithms, if else, that's not the basic composition of artificial intelligence. I read this excerpt in a book. This book is called Superintelligence, and it's very interesting. It's a book where the author analyzes what's going to happen with when the artificial intelligence gets superintelligence. There will be a point where computers will be much faster at doing absolutely everything that humans, etc. And well, he wrote this thing as well, that as soon as it works, no one calls it AI anymore. When we know AI is like, oh, it's magic. Before we call it magic 5 centuries ago, now we call it artificial intelligence. So there is a lot of buzzwords. Before I keep going with the talk, I would like to put a little bit of sense and explain you a little bit what each of those words means. Artificial intelligence is the science of making machines smart. When we have a system that let us drive a car autonomously, or when we have an assistant that is smart and is able to understand language and process it, that's artificial intelligence. Machine learning is the art of building machines that can learn. There are several types here as well. We can talk about supervised machine learning, unsupervised machine learning. For this purpose, we are going to focus on the neural networks. Because yeah, TensorFlow, if you know the framework, is based on neural networks, which is particularly an algorithm using machine learning. There are also different types of neural networks. We have the convolutional neural networks and a few more. But that's a very deep topic. I will try to keep it simple and pragmatic. I saw this classification somewhere else in Twitter as well. We have what could be called complex systems are the artificial intelligence and machine learning. Those fields need a specialist. It's an area of wisdom, of knowledge that requires a lot of training and experience. And a few things that sometimes get confused, the boundary is very fuzzy, is the statistical reasoning or the rule-based decision systems. Those are things that every programmer can do, as long as we're moving into the right side of the picture. We need more specialization on this work. How many people has been working here with neural networks? Okay, that's a good number. I personally did it when I was at the university, and for me, took some time until I could really understand them, because it was something very theoretical. I remember we had to implement by ourselves a neural network and define it on depending on the language, etc. But it's a very deep complex. I want to keep it, as I mentioned here, very simple. And yeah, let's see. Basically, a neural network works as a system that is able to find patterns. In a classical example, a neural network is able to identify if an image belongs to a particular type. So here we can see that we can send some images that are cats or dogs, and the neural network is able to say, okay, we are dealing here with a cat or with a dog. To train the neural networks, we need a massive amount of samples. Everything that can be digitalized can be trained or modeled within a neural network. So that means not only images, but we can also use sound samples or test samples. Neural networks are also used a lot in the field of semantical analysis. For example, let's say in Twitter you want to find if a particular string contains a positive or a negative test. That's something that can be achieved as well through neural networking, etc. And I actually would like to give you a few examples of practical applications that are being right now done using neural networks and machine learning. So in the case of, you probably know those applications from Google. If you guys use Android, you definitely know the assistant, the new assistant that is able to provide us many contextual support. We have the Gmail with the smart replies, where we have these three replies that are automatically provided to the user based on the context. We have of course, the search. The Photos application is amazing. I have one example that I would like to show you. They contain a lot of real-world machine learning. For example, this is I took this video with my emulator. I like Japan a lot. I go very often to Japan. This year I spent 3 months. And I took a lot of pictures with my phone. So if you go to the Google Photos app, if you have it installed and type something like Japan, it will identify pictures that have some connection with Japan. And you could say, this is based on the geolocation. It's not. It's also based on patterns. So the app is able to find a toridor, you know, those Japanese doors, or sushi, or pictures that you could identify as taken in Tokyo. So here, I think I can play it again. Yeah. So you see, I type in Japan, and you see that there is like this here in Kyoto, some sushi, some temples, etc. Try that in your app. It's surprising. You can also do it with things like tree or nature, and the app itself will perform through a neural network search. This immediate response we have, if you guys know Inbox or Gmail, when you open a message, you get a proposal of 3 messages that you can that are automatically created from the context, and you can use them to have it's called a smart reply. For example, something like, yes, I've done this thing, or let's gonna meet at this time, or no, I can't, but I have to send it. Here, for example, I was talking with one guy at a conference, and he said if I could go, and the response it provides me is like, yeah, I would like to attend, or no, I don't think I will be there. Here, yeah, would be was a similar. Well, in the second case, there is a guy asking me, saying if I was able to send a document, or if I was able to send a video, and the answers are, yes, I do, yes, I have, no, sorry. This, according to Google, is right now 12% of all the responses on mobile, which is not little. And as you can imagine, this is growing. Google Translate, that's one of my favorites. If I don't know if any person speaks here Chinese, probably not, but well. Before in Google Translate, the systems we used to translate was this phrase-based system. And it was basically, we have a sentence in English, we want to translate into, for example, German. So the translation was done roughly word by word, or trying to find an intermediate language like French, then translating from English to French, from French to German. And it was not very accurate. Here you can see that if we want to translate from Chinese a sentence that basically means, excuse me, what is the toilet? Using the old system, where will the restroom? We understand, there is some context, but the translation is pretty bad. Now, Google Translate is using a neural system. And the new translation is, excuse me, where is the toilet? Here you can see the translation quality. Up to the top level is the human translation, when we hire a professional translator that can take this text and can translate it. And the neural network quality, as you can see, is pretty similar right now to the human translation, the quality of a human translator. And this is getting better. The neural networks get better with time. They train more. They get more better input, better samples. So with the time, they might catch up with human translation. And as you can see, the phrase base is pretty under the standard we can see with the neural networks. I also see that some languages are more difficult to translate than others. So English and Spanish are relatively similar. There are like some Latin contexts, but Chinese and English or Chinese and Spanish are really different languages. So the success is not as much as with these other languages. I would like to show you a video which, let's see if the screen is nice to us. So now in the last version of Google Translate in the app, you can actually point out to some text, and the app will translate it for you locally, which is great. You know, before you have to make the request, and the request goes to a server, it gets back, that requires some time. But I want to show you this very immersive example. This has some sound. I find particularly amazing that it can keep the fonts, it can keep the color, and it can reorganize the text. So sometimes when the text translated needs 2 lines or it needs to change the paragraph, it's done automatically. And well, this is actually done locally. There is no there is obviously the images are not getting compressed and sent to any server, because this would not be possible. If you need to transmit the image, wait for the result and get it. Yeah. Well, that was just an excuse to play the music. What were we talking about? Okay, well, important thing, this is done locally, and that's where TensorFlow for mobile will come later. And yeah, in the case of mobile, if you guys have one of those devices, you can play into more things. I, for example, use this app a lot for Hangout. I get the smart proposals or the smart replies, and if I'm in a meeting or if I'm doing something, I can just very easily from the phone say that I will grab you later, whatever, to keep my my contact calm while I can keep doing what I want. And obviously here on those devices, we can make use of motion, GPS, whatever devices whatever sensors they have. Now, I've mentioned before, this demo I showed you from Google Translate was done locally. There is this confrontation between cloud versus mobile. Traditionally, all the machine learning has been, the interpretation has been done on the cloud because the cloud is faster, right? It's cheaper as well. A device does not have a lot of battery, a mobile device, so we want, or it might make sense if we send it and then get the result back, but this would not work for us as example as the one I showed you with Google Translate, because this needs to be done, resolved locally to have this immersive experience. If we need to connect to a REST API, send our emails, get it back, that's not going to happen. And in many situations, we need to do it on this end device, on the phone. Think, for example, of the cars that are now self-driving. If you want to perform any operation of having a model that you want to resolve and sees a signal contains a symbol or another one, you cannot send this through the internet, get the response back, and then see if this is a stop signal. By that time, you have killed already the person that is crossing. So yeah, the advantages of making it on mobile is that there is less traffic that we're generating, the response is way faster, and we can make use of the motion sensors. Now, TensorFlow. TensorFlow is an open source library for machine learning. This is the website. And today is the most popular machine learning framework on the web. There are a few more, Caffeine, etc. But TensorFlow has been, recently. Recently, Google released the mobile versions, but the framework has been there for a while. And what we can do with the framework is we can actually train models on Mac, Windows, on a GPU server, or a GPU or tensor processing unit on the cloud. And the prediction can be done on Android, iOS, and Raspberry. Yeah, so if we wait a couple of minutes, maybe we can try to change. I don't have more videos, but we can play the video again later. Did you guys knew that song, the one of Okay, well, let's see. Yeah, so, okay, since it's going to be the same. Well, I would like to provide, because, well, obviously we can trade it on our computer. That's one of the perks that we can do with TensorFlow. But there is this question, like, should I do it on the cloud? Should I do it on a GPU, etc.? Just as a comparison, this is a benchmark called CFAR10. And here it specifies how much time we need to train a set of 10 models with TensorFlow. So as an example, on a MacBook Pro, like the one I have, it would take 21.6 hours. I think the cool thing or the relevant thing here is that to train it in one GPU, we need 16 CPUs. And it's basically the same time. So yeah, GPUs are, if you need to train models, which is very often the big logic on this business, to have your own models and train them and make them very specific, a GPU is way faster, or a TPU, than using it on your machine. TensorFlow ecosystem, this is announced on the TensorFlow website. There are a few companies that are actually using TensorFlow. I think on the mobile part, Airbnb was doing something, and, well, of course, Google with all their products. Yeah, I'm going to explain you a model. There is this developer advocate from Google called Yufeng. He's from China, and he explained a model where he goes from training to app, from not having any, from having just an idea and moving into creating a model and making an app that is able to identify this model. And it's called, unsurprisingly, from training to app. The first step is to gather training data. Let's think. We want to use an app or create an app that is going to be able to identify a model, and we need to gather a lot of data. What would be your first idea to get a lot of samples? Sensors? Which kind of sensors? Yeah, absolutely. If you can, somebody has said video here. Yeah. So one idea for, in the case of images, would be to take just a lot of video, right? Because in a video we have a lot of frames per second, and each second is each frame basically is a sample. So imagine we want to find, may create a model of I don't know, like a glass can. Well, that was actually a energetic drink. Yeah, I was taking this video at my home, and that could work out. It's a very basic example. We just go through, we take a few minutes of videos. In a real case scenario, we would like to try different backgrounds. We would like to try different light conditions. We would like to try different distance, etc. That's just a very basic example, so you can understand the concept. Also, one guy was in another conference. He said that we could also do maybe like looking through Google Images and download a lot of set cases from, I don't know, Tree or whatever we want. But as I mentioned, one of the magics of the business core things here is to be able to have a really nice and adapted model to our purposes. So let's imagine we have this video already with a few thousand of frames, so we can use a tool like FFmpeg to move from this video into many different pictures and put them in a folder. We have all our positive samples there. And from there, we move into the training. I don't know, you probably know Google Cloud Storage. It's a very, well, like Amazon cloud. And Google has something that is less known, and is this cloud machine learning engine. It's basically a cloud engine where we can send them our samples, and they can train the model for us. It might make sense if our core model is not a generation of those TensorFlow units. It's cheaper, you need to take less care of the infrastructure, but obviously if your company is developing models, you want to keep that in-house. In that case, you would use TensorFlow on your own machine. For this example, I think it's enough. So we have all the images, we upload them to Google Cloud Storage, we go to the machine learning engine, we tell them, okay, train all those images and give me a model. I want to give you an overview of how this a convolutional neural network works. The convolutional neural networks are the neural networks that TensorFlow uses. You probably know this guy, Escher, is the guy, the crazy guy that makes these impossible designs where there is a stair that is always going up or always going down, etc. And imagine you guys have a puzzle like this, and you want to solve it. You have all the different pieces that compose this puzzle. What would be your first approach? That would be good, like anything in computer science, trying to solve the small problem, right? Finding patterns, finding colors, trying to make groups. That's exactly how a neural network works, actually. We could, well, this case is a little bit particular because it has only two colors. But we could start by, for example, separating white from the color that has some patterns. That would be a first initial step. Then when we have this separation, we could even go forward and say, okay, I can see that in this picture there are some patterns. We have the, okay. Yeah, we have the roof, and there are two different type of roofs. So we could start going into the pieces and trying to find exactly this pattern, and then making more farther groups and making more specialization until we start constructing our model and start having smaller parts. Here we can see, for example, that there is a stair, and the stair has some rect lines and some perpendicular lines, so it's a different type of a pattern. We could also start building the stairs step by step until we have something that resembles to the big picture. And step by step, we end up creating our puzzle, right? We put things together. This example is particularly hard because we only have the in the part that now are not covered, it's only just white pieces, so we need to find exactly which one fits in there or not. But this is exactly how a neural network works underneath. They try to find patterns that you previously trained them for, and they try to put them together and give you an answer. Is this the pattern I'm trained to identify or not? Now, to put some, this is a little bit more technical. TensorFlow uses a neural network called Inception 3, version 3. It has 48 layers. Each of those levels is a layer. And the question if for you probably is this too much or too little? To put it as on perspective, in 2013, using more than 4 layers was not feasible because there was no technology, there was no computational power. So, and each layer added exponential complexity to the network. So they have exploded literally with this last version 3. So now, let's say we have trained our model on the Google Cloud Machine engine, and now we need to adapt it for mobile. As it is trained, it doesn't work on TensorFlow for mobile. We need to make some adaptations. A model that is just trained weighs 80 megabytes, which might be a problem for a mobile application, right? Because the mobile applications need to be lightweight, and if the application has its downside and we're putting 2 models, 80 each, that could be a big problem. So what we do is we quantize them. That's the mathematical term. A model is basically a file with many float numbers of 32 bits. And what we do by quantizing them is reducing this into 16 bits. And you would think, is this losing a lot of efficiency? That's a very nice question, but neural networks are defined to be very tolerant of fuzzy input. So by eliminating this amount of bits, the network is not losing 50% of the accuracy it has. It's a very marginal one. Google claim is between 4 and 5. That actually is a very, it makes a lot of sense. And by doing that, we can downsize the file, the model, from 80 megabytes into 20. That means the model we will be using in our app moves from 80 to 20. It's already very different. Another thing and even if we want to, if size is a problem, because we need to train a lot of models, it depends on the problem, the business model we're trying to solve, we can use another Inception version. The version 1, when it has been quantized, is 7 megabytes, and might be still accurate for your application. One thing to consider is that in the case of Android, TensorFlow increases the APK size in 12 megabytes. So we have our app plus 12 megabytes plus the models we want to use inside. But yeah, let me think. So okay, we have the model. We have optimized it for mobile. We want to load it into our Android app. It also works for iOS. This is just an example with Android. And there is a further consideration here I want to show you. We can deliver the app with a model. That means when we are downloading the app, the APK from the Play Store, it's our APK plus 12 megabytes plus the models that are inside. Or we can just download them on demand, right? We could have them on Firebase or Google Cloud storage or Amazon storage, and we download them when we need them, which, in my opinion, makes more sense in most of the situations. Because imagine if you need to make an update, and every model is within the app, you need to publish the app again, and everybody needs to download it. That's way too much. Some people claim that this model is better, the one where the model is delivered with the app, for security reasons, which I don't think is really a good argument, because if you have a device that has been root, you just can download the APK and compile it, get the model. So it's not solving any real problem. Yeah, the TensorFlow community, some numbers, has 1,000 plus contributors, 22,000 plus commits, and 80 plus thousand repositories with the name TensorFlow. This last one I think is particularly cool. When I have free time, sometimes I Google, because there might be something new that you have missed. You can filter by number of stars, and I like that there is always one crazy person, generally from Japan, doing like very crazy ideas with TensorFlow, putting the open source code. So it's interesting in order to get some inspiration. The interest of TensorFlow has been growing together along with the interest of the machine learning searches. And yeah, I will try to go fast over the instructions to how to build and install to show you some demos. Well, Google claims it's very easy to build with Android Studio. I'm sorry, I do not fully agree with them. Do you guys know Bazel? Yeah, it's some build tool that I don't know why Google decided to use it for TensorFlow. Those are the instructions for Google. Take popcorn if you want. So you have to set the Bazel binary location in this place. You have to add the project to Android Studio. So far, so good. You have to install Bazel first. There are some instructions there, and how to install it takes some time. Only the version 0.6 work. The other ones break, and there is no documentation about it. You need to download the Android SDK, at least the 23, and you need to download the Android NDK 12b. With other ones, it also is broken. And I recommend to do it with the Android SDK manager. I had the NDK installed by myself, and it also breaks TensorFlow. You need to adapt your workspace file, change a few attributes here. Where is your SDK and your NDK? You need to run Bazel with this command. At this point, I think in my computer also broke something. That generates an APK. You can install an no, but I don't think so. Yeah, when the APK is done, then you need to install it. And that's a long process, right? Or you could download TensorFlow from the G-Center, right? Like with Maven or Gradle, we can specify the file, download it. But there is a problem, and is that the GUV to RGB conversion is not very effective, and the object tracking is not available, which defeats the purpose of using TensorFlow. This is changing very fast, and there are new versions of TensorFlow continuously, so might change in the near future. Now, few samples with Android. The API of Android and the Android SDK give us 3 examples: one to classify, detect, and stylize. The one for classifying, it uses Google Inception version 3 to label images. The model is very easy to swap. I will show you later, just changing a zip file. There is no person label. And if we click on the volume, we can see some statistics. This is an example. You can see here that the model is saying that those are Granny Smith apples. I think it's funny that it doesn't say apples. It specifies Granny Smith. So you can see the level of detail and the level of specialization you can use with TensorFlow. This is a video I recorded with my old Samsung Galaxy. And here is actually finding, if you can see, that this is a wallet. It says that this is an iPod, which is not really right because it's an iPhone. Here it says that this is a laptop. It also says that it's a keyboard, and this is the keyboard of a laptop. Yeah. Then I move it here. It tells me, it's interesting because it tells me it's a bottle of water, not only a bottle. So you can see that this is a model provided by Google. It's very general, but it's funny to see the things they've been doing, because this at the end means that a guy was behind providing a lot of positive examples. It also works when you saw a beer, a can of beer, it tells you that it's beer and it's not cola, etc. But as I say, probably in the real world, when you're developing models, you want to make them very specialized and be able to identify breeds of animals, as happens with another model. The sample for detecting, it's yeah, this is a screenshot, very easy. Draw bounding boxes around people. It's very useful to count objects, to see how many of the objects you have trained before are on the image. And there is no training yet supported, but as I mentioned, this might change anytime soon. And the last example for stylizing, it's well, it takes a real-time style transfer algorithm, and we can pick one style and mix between them, and it can train magenta models. Do you guys know magenta? It's a framework that Google did to generate art with a computer, or to generate music with a computer. With magenta, basically, we can specify, make me a classical composition, a piece of classical music. At one university, they actually made an experiment. They generate some classical music, put non-experts, that is people that are not musicians, and told them, okay, tell me if this is Bach or this is a computer. And pretty much they could not distinguish it. Okay, they are not experts, but that's pretty much like getting close to the Turing test. This is another video I recorded. So very basic, just, it's normally not that slow, but this phone is very old. And yeah, you see that I'm pointing out to a glass, and you can combine different styles. You can make deactivate one, activate the other one, and this is applied on real time to the image. Now, TensorFlow is written in C++. Android uses Kotlin or Java. So how can we use TensorFlow? There is something called the Android Inference Library. If you guys know the GNI or these bridge technologies, it's very easy. We just access from the Java code, the C++ code. Doesn't require a lot of complicated setup. Well, now building for iOS, it's way easier. We just need Xcode 8, the command line tools, install the automate and the lib tool, which if you are iOS developers, you likely have them installed already. There are 3 samples provided. In one of the samples, it's called simple, and as you can see, it's very simple. It just loads the model and tells you that the model is all right and some information about the model. They have another one with a camera, similar to the Detect one in Android, and it's very cool because it actually, as you can see here, there are some cats, and it's able to identify the breed of cats that are in the picture, not only that it's a cat or it's not a cat. You know, you always have to make samples with cats to be effective. And well, run inception in each frame that is on the camera, and the models can also be replaced very easily. And lately, a benchmark. This benchmark just loads a model and tells us how much it's taking to identify things, how long it takes, etc. I mentioned this thing of models are very easy to switch, so I would like to show you if I can move how this is done. This is the case of Android. In iOS, it's very similar as well. But this is basically the models that are being delivered with them. You see that we have 3 zip files. If you want to change and swap and put your model, you just need to train your model, put a zip file, specify it, and it will be loaded automatically on the app. So there is no extra work. Now let me come back to the presentation. And lately, I would like to show you about Raspberry Pi. They also offer TensorFlow and SDK for Raspberry Pi. I haven't played personally, but I've been checking a little bit what people does. And this was actually a guy from, of course, Japan, that has a cucumber factory, right? They have a lot of cucumbers, and when they collect them, there is a group of people that take them based on color, on size. They classify them in different boxes. And he said, well, maybe I can train different models with TensorFlow to do this automatically with a Raspberry Pi. You know, we have all these ideas all the time, right? And yeah, he made this video. It's very experimental, right? Just cheap Raspberry Pi and a camera that takes a picture of the cucumber. But it's amazing, right? Because he's able to take the size, and get rid of the people that was working there. Probably they would not be very happy with TensorFlow. Yeah, and it's something that maybe even we as humans are not as effective as the TensorFlow, because the TensorFlow is, well, it's a machine, it's more effective, it never gets tired, never goes on a strike. Yeah, so that's, well, before I finish, I would like to give you some resources. I've talked about TensorFlow and Magenta. If you haven't know, if you don't know them well, you just can go there and check the documentation. There is this code lab called TensorFlow for Poets. It's a code lab from Google where you can learn how to use TensorFlow to train models, how can you do it locally, the different things you can do with the SDK, and takes around 4 or 5 hours to complete. So I think it's a really cool starting point if you have more interest in TensorFlow. And before I finish, I would like to ask you for your feedback. So if you go to this address, bit.ly/UAmobile, and leave me your feedback of the talk, would you like more and less, and it can be everything, as long as it's constructive. That helps me later a lot to prepare future talks. I will send you a copy of a book I wrote with 100 questions and answers to find a job, or to interview candidates if you're on the other side of the field. And well, so far that's everything. Thanks for being a fantastic public. And if you guys have any question or something you want to talk about.
Thank you for great presentation. I have one question. Is model grows or makes larger or smaller depends on objects that we finding?
You mean the more objects we want to train
Yep.
to be detected?
Yep,
No,
yep,
they're pretty much standard. The output of the inception network is a file with many floats. It might be some variation, but it's minimal. So they get down into these 80 megabytes as a final file.
Thank you for a great presentation. Maybe it is the best I have seen today. I'm wondering about whether I could use that framework, for example, for trailer recognition or something like that.
For
trailer recognition in automotive industry.
trail recognition.
Yeah, trailer, yeah.
Well, it can be used for everything that can be digitalized. The example normally is images. It can be used for voice, for text, for anything that can be put into bytes. The only thing is that in the case of images, when it needs to be very specialized, you really need to provide a lot of examples with different conditions, with different, especially the illumination. I find that is something that needs to be done even on the dark and on different light to be finally effective.
Probably I could, for example, train the system with a lot of trailers from different views in different backgrounds or something like that. It might work, yeah?
So as an example, I was working at a company and they were doing this TensorFlow for a autonomous car to find signals. Not only that, but in combination with other sensors. And they set up like recording, like making this video recording of different signals, maybe during 2 weeks, and in different times of the day, like in the evening, in the night, in the morning, when it was cloudy, when it was not cloudy. Well, it's in Munich, so it's always cloudy, but and from different positions. And I think in total they ended up with like 3 hours of recording or something like that, and 3 hours with all the frames that belong to these 3 hours, and that was okay. It was pretty accurate. Depends a little bit always on the problem you're trying to solve.
Thank you. Also, I'm wondering about whether you have heard about machine learning for iOS or something like that, because Apple also provides their own libraries and frameworks. Maybe you could compare those frameworks for iOS and this TensorFlow. What could you?
So the framework for iOS has one problem, and is that only works for iOS. So you cannot use it in Android and Apple, as doesn't work with TensorFlow. they're not compatible. What you train with TensorFlow cannot be used with this iOS machine learning kit. But you can translate it. There are some open source libraries that take one model and translate to Apple, and then from Apple to to TensorFlow. And also the SDK from Apple cannot train. It's only done for interpretation. The model needs to be trained with caffeine, for example, and then Apple only reads it. I think that, yeah, if you need to solve the problem in Apple, in iOS devices, this framework from Apple is very integrated and works great with iOS. But there is always this thing: do you need to do it in iPhone and Android? Which market do you want to support? If you want to support both, I think TensorFlow is probably a better choice, because if not, you need to train twice or to keep the translation.
Thank you for the clarification.
You're welcome.
Hello, thank you. And my question is, is it possible to train a model that we already create by user responses, user feedback, or something like this?
To train a model?
Yes, after it was released to the mobile.
So you have released a model with a mobile, and you want to retrain it or improve it? Or
Improve.
No,
I want to improve.
It cannot be done with it only works in one direction. When you have created, which it's also a problem if you have a lot of data that you want to keep in a repository. I had this problem when I was working at this company, and the models kept getting better, right? Because you get more data, you train them again, and you cannot take the thing that already existed and complete and add or change anything. It's like a totally different model.
So I should have some kind like save these responses somewhere and then release new version of models.
That's very right. So in our case, we solved that by having an Amazon cloud entity with all the images we were training, and then from compiling them, we keep them in GitHub, and then from GitHub we were referring to, okay, the images that generate this model are in this folder. The images that generate this model are in this folder. But that's something that it would be great, actually, because you could maybe just release a short update, but it needs to be completely regenerated. And it also makes sense, because, for example, imagine you get a model, and this model can identify something. You could say, I'm going to get this model and increase it with my things, and maybe the other company would not be happy. That cannot work. The models are recreated all the time.
Yeah, okay, thank you.
You're welcome.
Is count of layers perceptrons configurable, and can I change, for example, threshold function in perceptrons?
You cannot change the layers. Inception 3 uses 48. Inception 2, I don't know how many. Inception 1, another set of layers. But you can change, I think in the case of the threshold of accuracy can be changed. There are a few parameters that you can change when you make the training. And that's, yeah, it's part of the TensorFlow frameworks. But the layers are that defines the type of network you have. You cannot use less or more.
Thank you.
You're welcome. Okay, we have 1 minute, so probably, guys, you want to have some coffee. If you have any question, feel free to grab me anytime today, and I will be happy to answer.